Hey guys, welcome back. So we are looking at 9.1, so we're in chapter 9 now, TV or not to be. So what we're looking at here is Venn diagrams, how to create and read. So for each Venn diagram provided, answer the questions. So how many students were surveyed? So we want to find the total number of students surveyed. So we have the 350 for the choir, the 225 for the band, the 375 that are outside of that. So we're adding all of these values together, plus that 50 in the middle, because that's a separate 50 from either the two numbers on the outside. So we add that all up, we end up with 1,000 students were surveyed. What were the students asked? So by the looks of it, they were asked about band and choir. So are you in band or choir? How many students are in both band and choir? Well, that's the overlap, so that'd be our 50 students. How many students are not in either band or choir? So notice we've got this number on the outside, that 375. That's going to be how many are not in either because they're not included in the circle part of the Venn diagram. So what's the probability that a randomly selected student would be in band? So we're looking at how many students are in band. We've got 225 plus the 50 that are in both. So really 275 out of 1,000, because that's how many total students were surveyed, which reduces down to 11 over 40, which equals about 27.5%. So looking at lots of probability here in this lesson, lots of probability. So your key word for this lesson is probability. So the next Venn diagram, there's lots more going on, but you're going to answer the questions just the same. Tell how many are represented, what the 95 means, what the 145. So looking at what some of these different values represent, since now we have 3 circles going on. And so you'll answer those questions provided. All right, interpreting a tree diagram to determine probability. Given the tree diagram below, answer the questions and determine the probabilities. The diagram represents the number of plate appearances during the first month of a minor league baseball season. How many times did a batter come to plate during this time period? So we're looking at how many total. So we're adding all of these together. So we've got the 1,193 plus the 417. So we're adding those because then it spreads out into the different kind of pitchers. So we're looking at just the batters. So we have 600 or 1,610. Based on this data, if you are a left-handed batter, what is the probability you will face a right-handed pitcher? So we want left-handed batter with a right-handed pitcher is 255. So 255 out of all the total left-handed batters, 417. And so that's going to give you 61% when you take and divide that. Based on this data, if you're a right-handed batter, what's the probability you will face a left-handed pitcher? Do the same idea. Go for right-handed batter, left-handed pitcher, divide the two to find your percent. What's the probability that a left-handed pitcher will be throwing for any given plate appearance? So we want to look at all the left-handed pitchers. We've got 693 and we've got 162. So if we take our 693 plus the 162, we get 855. So we're going to have 855 out of our 1,610. Divide that, and we end up with 53%. So you're going to finish out 14 and what observations you make about the data. All right, last section is basic probability. Find the probability of achieving success with each of the events below. So rolling an even number on a standard 6-sided die, a dice 1 through 6, there's 3 that are even, so 3 out of 6, which is 50%. Drawing a black card from a standard deck of cards, so half the cards are black, so 1/2 is 50%. Drawing an ace from a deck of cards. So for this, because there are 52 cards, there are 4 aces, so 4 out of 52, that's going to give you 7.7%. Now, notice we have a couple where we've got two different situations going on. So rolling a dice twice in a row and getting 2 3s, rolling a dice and getting, not that one, flipping a coin and getting heads 3 times in a row. But this one we're doing 2 things at once. So as a result, we want to take and look at the probability rolling a dice, getting 2 3s. So the probability of doing it once would be 1 out of 6. Doing it again would also be 1 out of 6. We multiply those, so we get 1 out of 36 chance, which is 2.8%. So just finding those probabilities and representing them as a percentage. All right, if you guys have any questions, feel free to ask. Have a wonderful day. Bye, guys.